Good day, guys. Welcome back to my YouTube channel. This is Nated Engineering Tarolo. Before we start this video, guys, do not forget to subscribe to my channel. Also comment and like. Please subscribe and share these videos to your fellow classmates, right? So now we have to deal with this flow-in channel, right? This is N6 fluid mechanics. It's N6, right? Want us to deal with it. Fine. Now we have this flow of water in a open channel. The flow of water in open channels, right? Okay, I want us to start by elaborating things here. Remember, I want us to discuss about is this formula. We call it benzene. Must know benzene. It's a benzene formula. Basin. What? Benzene formula. You must know this benzene formula. We know C it's equal to 87 over 1 plus K over square root, right? I. Oh, so there's no I here. That will be a velocity over M, right? This we call this benzene formula. We know this is a Chezy's formula, right? Chezy's constant. This is a Chezy's constant. Chezy. The Chezy's constant. This is a Chezy's constant. We know the formula for Chezy formula. Chezy formula. This is Chezy's constant. What about Chezy formula? Now we'll look at Chezy formula. I hope, okay, the camera is adjusted, right? Let us return here Chezy formula. We know that it states that the velocity is equal to constant. The Chezy's constant, multiply this over hydraulic mean depth, multiplied by the slope of the gradient. Apply by the gradient, right? This is what it's a velocity formula, right? Whereby if you want to find the rate of change, you know that rate of change is area multiplied by this velocity. The velocity here, you understand. But note, you must know when you apply this formula. Actually, there are laws you're supposed to understand when you apply this formula. You don't just apply that formula. You can apply, but you must know why do we actually apply that formula. There must be something that is constant there, you understand, so that you can apply that formula. There must be constant things there that needed to be included. Example, if you apply that, you must know that you must have a there must be constant things that are constant. Your I is supposed to be constant. You have the same I, right? Also there, you must know if you have the constant Q, which is the rate of change. You can apply that formula there. We have, and then there are constant area. Yeah, if it's the same, if this is the same, actually, most of the time, if this is the same and this is the same, then you can apply this formula. It's how you calculate the rate of change. If maybe you're given two objects, you understand, This is a square section, semicircle. If they have the same eye, gradient, with these two have the same eye, also have the same cross section, you understand, you can apply this formula. It's applicable, you understand. Then there you will calculate the quantity of flow. I hope you understand that. Right. You must know here K depend on the surface, the roughness of the surface. This depend on the surface, the roughness of the surface. This will be given, K will be given, this one is always, you will be given. It depends, maybe you're dealing with a dirty pipe, will give you dirty pipe in, and clean pipe, all and stuff. Then you'll be given the value of K, right? You'll be given the value of K, right? So this is the formula that you know. You're supposed to know this formula. It's there. You're supposed to know this formula, because if you are given K, you're supposed to use this formula, right? And then you must know, if you are given that K, you should use this formula. You must know this formula. Formula which C is equal to 87 over 1 plus K root M. Must know this formula. Basin formula, right? We must know this formula actually. Now I want us to discuss about hydraulic under hydraulic mean depth. Hydraulic mean depth under the flow fault in open channel. We must know this. I know it's denoted by what? M. It's M. The small letter M is hydraulic mean depth. You must know the hydraulic mean depth, right? The hydraulic mean depth under this topic, we know this. We can say this is the cross-sectional area of the stream. The stream must be divided, right? Must be divided by the width perimeter, right? Width perimeter. As you can see, this definition is clear. Hydraulic mean depth. You see, hydraulic mean depth. What is hydraulic mean depth? Is the cross-sectional area of the stream divided by the width perimeter. This is clear. This is it's just clear. It's just a clear stuff. Then, as you can see, it's just clear. Divided by the width perimeter, right? So since it's divided by the width perimeter, then we can derive the formula from this definition. Since it says, it's clear that we know that hydraulic mean depth is equal to what? The cross-sectional area. Area, no, it's an area. It's A represented by A over what? Over the width perimeter one. It's over the width perimeter, which is denoted by P there. Right. This definition is simply the formula. We apply that formula here. You can see the cross-sectional area. Here is the cross-sectional area of the stream divided. Here we divide by the weighted perimeter. Here is the weighted perimeter. So M is equal to area divided by P, weighted perimeter. From this definition, we understand, right? Cool. So let me erase here a bit. Take note about this. Take note there. Okay. Let's say now A. Let's say A, we are given a pipe. Let's say let it be a pipe, a half pipe, a half full pipe. Okay, which is a full flow. We have this pipe, but it's a half full flow. Then we have here it is. This is the pipe, but the water flow half is filled with water from this portion. It's half filled. It's a half only filled. This is water. This other part is empty. This is filled with water. This part it's half filled. This cross section, this part of the pipe is filled with water. As we know, this is the circle from here till here. We know this is the diameter, which that diameter is also equal to 2 multiplied by the radius. We know that is the diameter of the cross section, because the circle figure, it's a circle cross section, it's a circle object, right? Now we're still under this half pipe. Now we have discussed about hydraulic mean depth, which hydraulic mean depth is denoted by M, small letter m. Small letter m. We know this is, we said is what? It's a cross-sectional area, or it's a cross-sectional area over what? Over P weighted perimeter, right? Over weighted perimeter. Now, your mathematics is needed a bit. Your mathematics here is required a little bit here. Remember, when we're talking about the perimeter, let's say we are given an example. You are given a square shape object. Here we have A, B, C, D. Remember, a perimeter, maybe a perimeter, let's say now it's you here. We are walking, you're rounding, you're walking, you surround this box. From here at the corner, how you will do move? You'll move like this. If it's the road, you'll go like this to this direction. When you reach to this corner, you'll go upwards. When you reach to this corner, you'll go that side. When you reach this corner, you'll go downwards. You see, the way you move, you have formed what? A square. That means the distance that you have moved, the perimeter here, will be the sum of all those sides. The sum of the 4 sides. You're supposed to move. The sum of all of the 4 sides will be what? A plus B plus C plus D, right? You will sum up all the sides. You understand? You sum up all the sides. So now you're given. Now use the mathematics. Mathematically, this is this is a circle. So circle, when you move, let's say you are here from this point, it is you here, you are traveling, you'll walk this direction like this, right? Your direction will form what? A circle. But now mathematically, you cannot say this plus this plus this plus this. You're supposed to have a C because this is spherical. It is, you're supposed to know how to calculate the distance, the length of the circle. It's not straight like this. It's a circle. You must know how do we apply its distance. So this is a perimeter. I was doing an example. Now we have, let's focus on the on the circle. This is a half section. Remember, it's full. It's a full pipe, but it is half. Right. Now we are checking the mean depth of the half full flow. It's a half full flow. The water half here. This is a pipe like this. Here, this is what flowing, but flowing water halfly. So the water does not flow full. It's flowing only here. At the top, there's no water, right? That's the which we were focusing on this. We are checking this cross section, right? The front view. This is the front view of this pipe, right? This is the front view. This is to water, right? So we know hydraulic mean depth is equal to area over perimeter, over weighted perimeter. Okay, area. Remember, area of the circle. Area is of the circle, right? But now it's the same. Is the circle? Yeah, it's of the not circle. Circle is a circle, right? But now it's the same because it is half. It is half the water. We're focusing on the. Okay, let me just write the formula here. Remember how to calculate the area of circle. We know that it's pi over 4d squared, right? But this is what is the full one. If the water filling up this section, let's say there's water all over, but now here there is half. It is half. Since it is half, we'll multiply this by what? 1 over 2, right? Its area will multiply by 1 over 2 because it is half. So here we'll multiply this by 1 over 2. You understand this? We will multiply this by 1 over 2. Mathematical, when you multiply this, remember that when you multiply, numerator multiplies with the numerator, denominator multiplies with the denominator, right? So when you multiply this, we'll focus on this part here. When you multiply this, we'll multiply 1 with the pi, 2 with 4. This will be pi over 8 d squared, right? Remember, this is the same semicircle. This is the same. Here it's a. This is what is. It is a cross section of this because it's a half. It is a half pipe, right? Now we come here. We know that is pi over 8. It's pi over 8, right? D squared over, let me just small capital T, but it's fine, you can say. Let me just use the small capital T. You know why? You know that 8 over pi over 8 d squared. This is an area of the circle. Now, what about P of the circle? This is mathematics. Remember the perimeter. You must know this formula. Your mathematics. The perimeter of the. Remember the perimeter of these things of the circle. You must remember the perimeter of the circle. It's pi d. This is the perimeter. It's pi d. But full circle must be full. Is pi d. What about If it is a half, we remove this, it become like this. Obviously, if it is half, that means we multiply this by 1/2. We want to half this, we cut it, we left with a half. Now suppose here to multiply by 1/2, it's the same as dividing by what? By 2, right? Because now remember, dealing with the half, we have this. When you have that, you know this is P, it's 1/2 pi d. Yes, we understand. Pi d. This is it's half filled. This is half perimeter of this thing. But the full one, for the full, is pi d. If it is a full circle, you understand? Must be pi d, the perimeter of the circle. This is mathematics, right? Okay. Let me. So we know this. It's equal. It's over. We know the perimeter here. It's 1/2 pi d because it's a half, right? It's a half. This is also a half. Remember now, mathematical, you take this on your calculator, punch this on your calculator because these are constant, and then mathematical, divide that. When you divide, you're supposed to divide this mathematical. When you divide this mathematical, that will be pi multiplied by 2, right? Over 2/8. Then d squared, you subtract the exponents, bases are the same here, right? When you punch this on your calculator, you're supposed to get 0.25 d. 0.25 d. This will be equal to 0.25 d. Remember, this is what? It's M. It's hydraulic what? Mean depth. This is M. It's a hydraulic mean depth. The hydraulic mean depth, but it's M, hydraulic mean depth, right? Oh, sorry about that. Oh, sorry about that. Sorry about that. Let me adjust a bit. Sorry about that. Okay, sorry about that. Let me adjust this. Okay, it's fine. Good. We have this in terms of what? In terms of a diameter, in terms of d, because we don't know the value of d, right? This is how you find what? The mean depth of the full flow. Remember, we're focusing on the water. The water is a thing here. We're focusing where this water, the portion that is empty, there's no what? We neglected. We are all right. Now let us check B. I want us to check a rectangular channel. Rectangular channels. Right, rectangular we're talking about. Here it's a rectangular. Right, rectangular channel. Obviously this one is filled with water. It's filled with water, but it's not closed here on the top. This is water. Let me just do like this. This is water. Water, and up here, this is just water. Here is open to the atmospheric, is not closed, right? Just, this is a flow. This is water there. That is water. Good. We know mathematical. We know this. We're taking from where the water starts. water starts here and here at the bottom. We know this supposed to become what? A depth. It's a depth, this one, which is the depth. D is equal to the depth, right? Then here we have what? B, or B, which is what? It's a base from here until there. It's a base with, it's a base. That is the base, right? From there until there, it's a base, right? It's a base, right? Now let's look M. What is our M? Hydraulic mean depth, we know, is equal to area over P. You must know this formula. You must know this formula. We know this is an area of the cross section where the water starts. We don't take this, don't consider this portion here, this little portion. Why? There's no water. Let me extend this so that you'll understand. I want you, if they trick you, let me extend this like this. Yeah, I want to extend it like that. Here, do not take, depth does not start here until there in this topic. This will be wrong. We consider where water ends and where water starts. Here it's our depth. Water is this portion. Only this portion that we'll consider. We'll consider this portion from here till here, right? That means we won't consider from here. We consider the water, the portion that is with water. You see, this portion is this one. Start from here, it ends here. You understand? The portion. Note this portion here. From here until there, we don't consider this because it's empty. As you can see, there's no water. Let me do that. Consider only that part there when we're dealing with the area. Alright. The area, we know the area of the rectangle. We know the area most. The area, we know that is b multiplied by what? By d. It's height multiplied by base, which is the depth. Right. We know that this formula, it's A multiplied by what? By depth D. What about, right? What is this? Is D is B multiplied by D. This is an area. Remember, this is area. This is area. What about the pyramid? Remember, I've talked about the pyramid. Remember I've talked. Let's say you start from this point. It's water here at the corner. You travel, you move. This is you. You travel, you reach to this point, right? This corner. You move. You'll reach where? To this point, right? To this corner. Then you travel, you'll reach to this point. You cannot travel here. There is water. You'll sink, or you suppose now, this is a what? You're supposed to go on the top. Now we don't consider, only, remember, the weighted pyramid is the part which is in contact with what? Here it's in contact with what? It's in contact with what? Look, this part is in contact with what? It's in contact with what? What about this part? There's nothing here, there's no pipe, as you can see. So it's not contact with what? How many sides which is in contact with what is this? 1, 2, 3. This rectangle, yeah, understand? This is what is this one? It's a perimeter. Remember, I've defined what is weighted perimeter. Remember, the weighted perimeter. Remember, it's the portion which is in contact with water, or a portion in the pipe that is in contact with water. Remember, here this is in contact. It's touching this. What is touching this depth here? Is touching this pipe or whatever. It's touching here. It's touching, but what about here? There's nothing here. There's no pipe, as you can see. Similar here. The water is touching only these surfaces. How many of them? It's 1, 2, 3. So we'll focus what? On to when you go, you're supposed to remember, when you're talking about perimeter, we will add the sides 1, 2, 3. But remember now, this side here is D. It's a depth. Also, here will be what? A depth. This thing is similar. Remember, when you have a rectangle, these sides will be equal. If you have a D, this side also will have a D, we have B. But now why we don't consider this B at the top is because it is not contact with what is weathered pyramid. But here is like this, as you can see. Here is exposed to the atmospheric, is not contact with, we do not contact with the pipe, right? This word. So we consider these three sides. Then as we consider these three sides, we know we have 1, 2, 3. We add. This thing is the same. We have 1, 2, 3. We have 1, 2, 3, which is D plus B plus D. Right. Mathematical, these are the same. Will be 2D plus what? B. We understand. This is what is P, pyramid. We add those things. When you add 1, 2, will be 2D plus you have 1 of B. You understand that? So we know here we have this is equally hydraulic mean depth, is area, which is base multiplied by depth. Then we have this is B plus 2D. This is M. Here it's a formula. Supposed to know this formula. Simple like that. You just apply your mathematics. You're supposed not to cram. Just apply your mathematics there. Apply the mathematics. You understand? Right. Hopefully you understand that. Apply the mathematics. Now we're done with the rectangle, right? Simple like that. It's just simple as simple. Right. Okay, we did this. Let us go to let us check other shapes. We'll be dealing with 4 shapes. 5 shapes, yeah, I'm sure it's 5 shapes. Ne? Most will be 4 or 5, yeah, 5 shapes. N6 will be 5 shapes, not more than 5 shapes. That we'll look at 5 shapes, actually, but mostly 4 shapes. Okay, now we're dealing with this one. Must be a semi. Let's see, semicircle. This is a semicircle floor. This is not a full half. There they will trick you. Remember, when it's full, you just consider it's the same as the same. You don't consider the part that is not contact with water. Remember this one, they give you some, this is the shape like this. The pipe also, it's a semicircle pipe. This is a wonder. It's a semicircle pipe. Right, it's a semicircle pipe. So let me show these little things like this so that you will see this is what. Don't think that is closed here at the top. Let me just do like this a little bit. Why I'm doing this, I'm trying to show this is exposed to the atmospheric. It's open there. Something like this pipe is open there. You understand? It's open. But here is filled with water. It's filled with water. The side that is filled with water is only something like this. The water filling only this. Not here on the top. Here is exposed to the atmospheric. You're supposed to know that. Right. This will be the same as that one. Just that one. It was trick. They were just want to trick you. If like they give you fuel, but they put out water. If they put out water, you focus where? On this half. This is the same thing. It's one and the same thing. Just here we're supposed to ignore this. They just trick you there. Okay, we know M is equal to area multiplied by weighted perimeter. Guys, you know the area of that thing. It's a half one. Remember, we know that the area of the circle is pi over 4 multiplied by d squared. But now it's the same. That means it's half. It's a half. Same mean half. You multiply by what? You have also this. Remember, this is for full. Multiply by 1 over 2 again. To have this, multiply by 1 over 2. Just multiply by 1 over 2. Right. so that you have this. Then is that area over with the perimeter. Remember the perimeter I said is pi d is for the full. But what about the half? The half, what about half? You have the perimeter multiply by 1 over 2. It's the same as like, or you divide by 2. Same stuff there. Divide by 2. Remember full one, P full must be equal to pi d. P half must be equal to pi d multiplied by 1 over 2. Multiplied by 1 over 2. So this is half will be pi d multiplied by 1 over 2, right? Because it's a half. Then we know mathematical, this and this will cancel. Then here we have 2 of d, will cancel 1, will cancel with this 1. There will be left with, remember, then this pi will left with something like this, pi over 4 d on the top, all over pi, right? Then mathematically, you punch this on your calculator. Punch that on your calculator, right? As you punch that on your calculator, supposed to punch that on where? Or on the calculator. When you punch that, you're supposed to get this is 0. You're supposed to get this is 0.25d, right? 0.25d. It seems 0.25d, right? This is m. That means it's half over to 0.25d, right? In terms of the m, hydraulic mean depth. We're done with that. Now we go with, but if you check here, the depth is, no, it cannot be d, must be radius. Is depth, the depth here is radius. Remember is half, that means the depth is radius. The depth there is radius. The depth of this thing is r. That is r here, from here until there, this is d. Understand the diameter? Good. That is d. We're done with this. One task again, let us check d. Square channel. Square channels. Square channels. We know that the square, remember all sides is proportion, all sides are proportional, actually equal. Square, let me just write the square here. All sides are equal. Here, if it's L, will be L all over. L, 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 L. All sides are equal, right? We want M. Hydraulic mean depth. We know this is equal to area multiplied by P. What is the area of this? We multiply enormous. I hope that you enormous. These things are the same. Is L multiplied by L will be L squared. You reach a square. Yeah, will be L multiplied by L, right? Which is L squared. Here is the perimeter, okay? This is filled with water. Let me extend here to show this is exposed to the atmospheric. Let me show this area like this. Yeah, this air. But they will not show, you must know this. The atmospheric, yeah, is exposed to example like that. Now we're focusing here. 1, 2, 3. Remember, if you start here, you move. You go to this point. Also, you come to this point. You see, you will travel what? You will form 3 sides. You'll have 3 sides. 1, 2, 3. Now you add. You look what? It's 1, 2, 3. There you add. How many L's? 3 L's. L plus L plus L is equal to what? Mathematical 1, 2, 3 will be 3L. That is P. P will be what? 3L. Here, this side, only this side that are in contact of the pipe. This is pipe. It's a pipe which is a square one. The water will only touch this side, this channel. You see the water. But here there's nothing there on the top. There's no pipe. So this is the formula. When you apply this, it's 1 here. Remember, here it is 1. You can punch this on your calculator. This is the same as 1 over 3 L squared over L. Punch this on your calculator. 1 over 3. Mathematically, you minus the exponents there. When you minus the exponents, when you punch this, it's supposed to get 0,333. This will cancel, minus by 1. Remember, if the bases are the same, L squared multiplied by L, this is the same as L squared minus 1. It's a mathematics. L squared multiplied by L minus 1. Yeah, you subtract that. This will be equal to what? L in terms of L, but this is what it's M in terms of L, right? I hope you understand that. That is L 0,33 L, right? 0,33 L. Hope you understand this. This is the water. It's a flow. Water. Understand? Now, hope you understand that. Hope you understand this. Hope you understand. This was just an intro, guys. This is an introduction. This is an introduction. Good. It's an introduction. Introduction. Please, guys, do not forget to subscribe to my YouTube channel. Hence, I will be posting some new videos. I will post videos on this topic, flow in water, the flow of water in open channels. Like after I'm done with this video, as I'm done with this video, I will record another video again. Will be problem 2. We move forward. What you're supposed to do, just subscribe and stay notified. When you subscribe, when I post the new videos, you'll be notified. Thank you, guys, and share this to your classmates and also comment. I'm just showing up, just paraphrasing this. Then we'll go to we'll deal with some problem. We'll look at these examples. I just want to explain this. It's on your textbook M6. I know this thing is on your textbook. It's fluid mechanics M6. These are the same things there. And then these are the examples that are on your textbooks. So I'm just trying to explain it with what you have so that you'll understand. Okay, thank you.